Welcome to Mr. Yi's tutorial on dihybrid crosses. I will start out with an example problem. I will start with let's try a turtle. Let's start with a turtle. So, we have two turtles, and here are the characteristics. We're going to have a heterozygous green shell along with a homozygous dominant long neck. And this is going to be the male. Then we're going to cross them, mate them, with another turtle, female turtle that is homozygous recessive purple shell, and she is also homozygous short neck, and this is going to be the female. So our first step to solve this problem, to figure out the probability of the offspring, is to figure out the genotype of the parents. Okay. Now I'm going to give you the alleles for the problem. Big G stands for a green shell. Little g is a purple shell. And then big N is going to be a long neck. And little n is going to be a short neck. Okay, so looking at the parents, the male is going to be a heterozygous green shell. So to make a heterozygous green shell is big G, little g. A homozygous dominant long neck is going to be big N, big N. So that is our male. And then we have our female. She is going to be homozygous recessive purple shell. So homozygous recessive purple, little g, and then we have homozygous short neck, which is going to be two little n's. So these are the genotypes for the parents. Now going on to step 2, I'm going to scroll down for some more room. Step 2 is to figure out the combination of alleles. So we're going to take, let's take the male first. So the male, and then we're going to distribute again. Take the first letter and combine it with the third letter, and we're going to write down the combinations that we get. So we are going to get big G, big N. We're going to do this again from the first one, but now to the last one. And we notice we already wrote big G and big N, so we do not need to write repeats. So we do not write it again. We go to the second letter, combine it with the third, little g, big N, and then we take the second one and combine it with the last one. And again, we have a repeat, so we don't write it. Now, over to the female. The female, same thing. Little g, little n. Do the same thing. Oh, it happens to be the same thing, so we don't write anything. And these are the same ones, so we don't write anything. So there is only 2 here and 1 here. Now, our third step is to do the Putnam square. Now, remember, in a normal monohybrid, we would have just made a simple 4 squares and put the letters on top to figure out what is going on. But in this case, these combination alleles that we just did, these counts, tells us the size of the grid. So this is going to be a 2 by 1. So a 2 by 1 looks like this. 2 columns, 1 row. Okay. So we go ahead and put the letters. So big G, big N up here, little g, big N over here, little g, little n. Okay. Now we go ahead and combine them together. Now you may be wondering, Mr. Yi, do I need to write all the G's and the N's together? So for example, can I write it like this? Yeah, you can write it like that, but it's going to make it very difficult to see the matching letters. So I would advise putting all the G's together. So you put all the G's together and all the N's together. And also to put the capital letters first, because those are going to be the important ones telling you if the trait is going to be expressed or not. Okay, so let me go ahead and erase all of this. Okay, so to finish off this problem, we now need step number 4. So step number 4, and G stands for the genotype. Just like in monohybrids, we are going to write down everything that we have in the Punnett square, all the different combinations of boxes. So our first one is big G, big N, little n. Now, because there's only one box, two boxes, it's pretty easy to not get lost in the count. But later on, it's going to be advisable to start putting like marks indicating that, yes, I did take care of that box, I did write it down, so you don't get lost. You'll see what I mean in the next example, dihybrid cross. So going back to this problem, big G, big N, little n, we have how many? We only found one of that specific combination. We go on to the next one, little g, big N, little n. How many of those do we have? We have 1. And to finish it off, how many boxes do we have? We have 2 boxes. So our probability of getting this particular genotypes are 1/2. And then finally, our last one is phenotypes, where we're going to interpret what the genotypes we just wrote to mean. So I'm going to write out our alleles one more time. And it's long, and little n is short. Okay, so this one here, that is green with a long neck. And how many did we write? We wrote 1. So our next one is purple, and that is going to be long. And how many did we write? We wrote 1. How many boxes? We have 2. And that is it. So I hope this example of a dihybrid cross is going to benefit you, and stay tuned for part B, our second example, in another video. Thank you.